Oh my god, right.
That looks like
I need to, wait a minute. I can't see because of that thing. There we go. Right. So basically, it's a look at modern warfare, and not Call of Duty. We all know Call of Duty 4 was the best, but it's not what it's about. So I am Kaitlyn Garratley. I'm in the Hacking Society at Abertay. You will see us, we are everywhere. There's hoodies all over the place. I am a second year student doing ethical hacking. I would also just like to point out all the figures and numbers in this have been found from various research, and I can give you, I will send all this research over email, and my email address is at the end.
Woohoo, spam.
So, what's this about? Basically, it's just a brief look into the costs to produce both parts of war. It's the cyber and the real warfare, I suppose, including the tanks and things. In particular, I'm looking at the M1 Abrams, which is a tank commonly used in America, and the very well-known Stuxnet. So why? And I apologise for my slide. It didn't like it. So with advancements in technology today, it's becoming obvious that we need to look into computers and technology. Not only warfare, including tanks, bombs, and soldiers, are the way forward. In this comparison, the steps have been generalised to get the best view, to show the stages in the production for each item. No, that's annoying me already. I can go there instead. The M1 tank, have I gone back? It's already gone bad. So the M1 tank has been used, changed, and advanced over the years in the United States, and as many people will know, the Stuxnet piece of malware Stuxnet was affected in Iran's nuclear systems. So the M1 Abrams. This is my list of basically how I believe it's generally made. So it's, as I said, it's a tank used in America. It was in wars such as the Afghan and the Gulf Wars. Over 9,000 have been built. It was built since 1980. It's been built in the Lima tank plant in Lima, funnily enough, and it weighs about 67.6 tons. So as with anything going into production, there has to be a sufficient amount of research. Oh my god, right? Research to ensure the product can be used and is needed, really. The research difference, as you can imagine, with each product. As you'd expect, you'd need research into materials, weapons, new and old technology, and the obvious things like the colour. This would take a number of people, all specialising in their old fields. In particular, a munitions expert would look into the best ways to protect the tank, both with weaponry and armament, which I can't say. This research could take months before it's ready to actually go into design stage. The design stage is obviously closely linked, with ideas bouncing back and forward. The design depends on the different materials needed, and the different materials and different options needed on the tank, obviously. This stage could take time. It could take months before a prototype is even ready to be built. Then you have a factory. You can't just produce the tank out of thin air. The next stage would obviously be to make the prototype, so you need the factory. You need the people in the factory, and you might even need to build a factory. And this is automatically a huge initial financial dedication. You need your machinery. There needs to be individual parts machinery. There needs to be machinery to put it all together. It's not an easy, you can't just go in and build a tank. And specially designed, it's not going to be cheap to buy. So the materials for the tank, with a single ton of raw unmachined steel costing currently around $380 US, the weight translates at 60 tons to $22,000. So you can imagine that alone, just for steel, is an automatic extreme cost. In addition to these materials, you need the insides of the tank, such as the copper for the wiring, the glass for the screens, the computer systems, and the comfy seats, let's face it. So after this, you'd go back to the factory. Then you need your staff. As with any company, there's different tiers. So as a general overview, this is taken as of the 23rd of April, 2014, and it's the general per annum for America. Your general factory worker earns roughly $29,000 per annum. Your engineering equipment engineer earns roughly $41,000. $41,000. Your machine design engineers will earn $77,000. As well as this, you have your cleaners, your HR, your admin, your security, and obviously just everyone. So before you can even use it, it needs to be tested. Before you can test it, you need a methodology. The exact criteria, the tests themselves, this can include specialist tracks or courses, different locations, different attacks on the tank itself. So therefore, you need to build another prototype. You've just got rid of your tank. You need to test the onboard systems, such as fire control and navigations. Once these tests have been done, let's face it, more design, more research, more everything is going to go in. So to progress, we're going to say the tank was brilliant. We're putting it into progress. So you go into production. When a product goes into production, there's still many costs to think of. With 9,200 made at roughly $6.21 million for each one, if I was to go and buy every unit today, at today's current figures, not considering they were not built now, it would be $57,132 million just for these tanks alone. That's not including the costs behind them. On top of these costs, you'd have to obviously do all the normal factory costs. You'd need to pay the electricity bill. Like, you need the electricity. Then you'd need to train your soldiers. You can't just give them a tank. So as well as normal training and as well as the training that you'd normally go through, you have to have your additional training to operate the vehicle. For each tank, there's 4 soldiers trained: a tank commander, the gun operator, the gun loader, and of course the driver. Then you need to get your tank to its destination. This can be the other side of the world, it can be here. Either way, this has to be done through ships or planes, or it doesn't just fly itself.
It does in the 18.
Pardon?
It does in the 18.
Yeah.
It's okay, you can tell him to shut up.
Yeah. My dad will get you. Like.
It's okay, dear.
So, once you've got your tank to its destination, you have to think of the running costs. The ammunition at $3,000 for a basic high explosive round, and you're not just going to use one, like you're straight shot. I doubt it. Then you have to fuel a 2,000 litre diesel tank. And then obviously then you have the wear and tear costs, and then you have to pay the people to use it. As you can see, the costs and the steps just spiral and they loop into each other. And depending on the costs, depending on the economy, you're always going to have different costs and different expenditures. So Stuxnet, as it's a well-known malware, you all know it. It hit Iran in roughly 2010. It was a worm that infiltrated systems and then spread. It rootkitted itself to hide all processes and servers it was running. So, not anyone can code in this example, Stuxnet. You've got to, each coder writes differently, and you have to finding the best one is an important job. The coder would be expected to have a high background and knowledge in different areas of malware, and also excellent understanding of code. Basically as well, you can't tell, obviously here there's not as many, but you can't tell everyone what you're intending to do. So here you'd have to do all your tests and all your background research on these coders. Oh, that's bad. So you'd have to go into research. So before the code could actually go out, you have to check code that's been done and if it actually can you get into the system you're trying to infiltrate? What will the code need to be done? This is going to be really rushed now, I'm sorry. Then the product needs to be designed. This includes code, how it's hidden, and what it's going to do when it gets there. This can take a long time depending on how much you actually know about your system. So then you need to write the code, which even with multiple coders is going to take months. Everyone codes differently. Putting all this code together, it's a lot of problems. So then you test the code. You need to try and put it into a similar system that it will be going into. They all go through the design stages, the writing, the testing numerous times. We all know that your program is never going to work first time. Then you're going to have to get it in. It's a very protected secret how it actually got into Iran in the first place. But one speculation has come slightly that it got through the completely air-gapped system through a USB. A key problem is always going to be getting the virus into the system. With different security protocols placed, these have to be all taken into consideration. So this is basically the aftermath of both of these. The M1 Abrams has been used in many wars. For this example, I'm going to use the Gulf War. People began to suffer on the first day due to high pollution in the sea. The smoke produced by wild oil fires killed off not only wildlife, but suffocated people. It is estimated that on average, the oil loss per day was $115 million. Various sites claim that the US, as in our own casualties, well not our own, but their own casualties, were 258 deaths and 849 wounded. Basically, it's just our own soldiers are going out there and dying and being injured. It was said that at least 23 of these tanks were damaged beyond repair in this war. Oh, sorry, ignore that. Stuxnet, the virus, is only speculated because obviously it's Iran. It said that it put the process of enriching uranium used for nuclear weaponry at least 2 years back. The virus was then found in other systems across the world from the worm spreading itself. Now, post Stuxnet, it's taken into account that elite coding can be used. So, what is my point? With countries now dependent on their infrastructures to do just about anything, it's vital to think that the use of computers in warfare today. Is it worth sending tanks and soldiers into a war zone where they could end up dying? Is it worth our own casualties rates rising and the millions, even billions of pounds in production, clean up and training? But at the same time, do we need the boots on the ground? It is often the case we need the soldiers out there. Each war environment has its own needs, conditions, and almost rules to abide by. Thank you. All my sources can be sent to this email address above, kgarratley@gmail.com. Enjoy the spam. Thank you for letting me speak today. It was great. Are there any questions?